Welcome. This is a video on our application. It's a Datalog-based tool designed for schema evolution in NoSQL databases. Let's assume that upon a new release of an application, data which is already stored in our SQL databases may become outdated. Therefore, we developed a tool that enables eager and also lazy migration on data which is stored in JSON documents. For the demo, we use existing JSON files which illustrate a gaming app consisting of player and mission entities. At the beginning, each player has an ID, a name, a score, and a timestamp. The mission entities also have an ID, a title, a priority, and a player ID with a reference to the player that owns this mission, as well as a timestamp. So let's take a look at the application now. In the command prompt above, you can enter schema evolution operations that lead to a new database state. This includes commands for adding, deleting, copying, or moving attributes, as well as get and put calls for reading and writing data. In the middle, you can see the entities of our sample database. We have an extra area for eager migration and for lazy migration, so that we can compare the results later on. Query results will be displayed in the text area below. Now let's add a new attribute point to player with a default value of 100. As you can see in the eager approach, all player entities were migrated to the new schema version at once. Please note that if there's more than one player with the same ID, the one with the highest timestamp will be updated. That's why we got 3 new player entities with new attribute points and current timestamp. Each new database entry is also marked with a number of the related schema version. Player 1 objects belong to version 1 of the player schema, player 2 objects belong to the new schema version. On the other hand, nothing has changed in the lazy area because no data objects have been accessed yet. As we have mentioned, all comments are applied with the help of Datalog rules. If you are interested in the generated rules, you can enable the rules view, but we won't discuss these rules here. For more information about the generated Datalog rules, please refer to the paper which is linked in the video description. In the next step, we assume that the application requests a player entity. We are able to read entities from the database using the get command. For our example, we want to get the player with ID 2. This player has the name Bart. As you can see, a new player Bart with a new schema was added to the lazy database. In contrast, nothing has changed for eager migration, as all entities were already updated. In addition, the results of the get command are displayed here. They are equal on both sides and also up to date. Now let's see what happens if we combine two schema changes. In the first step, the score of all player entities will be copied to the correlated mission, marked by the attribute player ID, PID, in the mission's entity. You can see that for eager migration, all the missions were updated. For the lazy one, nothing was persisted. Afterwards, we suppose that the attribute priority for each mission has to be deleted. Again, with eager migration, all the mission entities were persisted and has to be written to database, which would increase the application downtime upon a new release of the code. In the next step, let's assume the mission with the title Go to Library has to be accomplished, and therefore we have to load it from the database into our application. For this case, we have to get the mission with ID 1. As you can see here, the results for both migration variants are equal. So from the user's point of view, it is transparent whether the migration was eager or lazy. But from database side, for eager migration, the number of total entries is 16, and for lazy migration only 11. In case mission with ID 3, Go to Work, has never been used again. It has no influence on our gaming app. Anyway, for eager migration, the update of this legacy entity generates unnecessary costs.
So for agile development against NoSQL data stores, the Datalog-based protocol for lazy data migration, which is implemented in the shown demo, is a good alternative to minimize application downtime between new software releases.